Yo, what's going on, guys? What's happening? So, right now, what we're going to talk about are current sources. As you can see, we have a completely new component in our circuit, and this is called a current source. Now, a current source is exactly what it sounds like. In reality, you can consider anything a current source. Um, this resistor right here can be turned into a current source. This resistor can't be turned into a current source. Now, um, hold on. All right. So as I was saying, um, the current source. Now, when you get into more advanced electrical engineering, I don't know they consider just anything a current source, but I mean, as of right now, that analogy works. So I'm just going to use that analogy. Basically, anything can be turned into a current source because everything produces a current, right? Exactly. So what we're going to do here is we're going to label our current sources positive and negative terminals, right? The upside of the arrow is the positive terminal of the arrow, and the downside of the arrow is the negative terminal area. And yes, you need to remember this. Like, if you don't remember anything else in this video, you have to remember this. Current sources have positive and negative terminals because if you don't remember that, they will bite you in the ass when you start doing problems. So you have to remember this. I want you guys to like drill that in your head right now. That current sources have a positive and negative terminal. Okay, cool. Now what we're going to do is, of course, the first thing we do, as any skilled electrical engineer should do, is label the points we already know. So we know that's 0 volts because that's ground, right? Ground will always be 0 volts. So we know that's 0 volts, right? Well, I won't say ground will always be 0 volts, but theoretically it will always be 0 volts, right? Like in theory, it will always be 0 volts. So we got 20 volts here because obviously we got 0 volts here, so we're gonna have the voltage. I'm not gonna explain it again. This is gonna be the last time I explain this. The voltage difference of the battery, obviously, is going to be 20 volts, right? Because it's labeled as a 20-volt battery, so that means there's a voltage difference of 20 across the battery. Here we got 0 volts, here we got 20 volts. That's a difference of 20 volts. Now, that will probably be the last time I explain that again. So, yeah, at least in detailed terms. All right, so we got 20 volts there, and we don't know the voltage here. So, we are going to label our essential node, which is VA, right? Our essential node here, which is VA. So let's do that. All right, now what do we want to do? All right, so now we just want to start solving this problem, obviously. So we're going to go from here. We're going to go through the 20-volt battery, going from low potential to high potential. That's a voltage rise of 20 volts. So we're going to go here, and we're going to stop here, and Ohm's law is going to take place. So I'm just going to write that one equation we have. I'm done writing the other equations. I'm just going to write this one equation. So voltage difference of the resistor divided by the resistance of the wire is going to equal the current of the wire, right? Current of the wire, right? I'm going to write that equation there. Here we go. The equation, nice and handy for us. All right. So now let's label our points of the battery. Now we know, obviously, VA is the high potential, theoretically here. So let's label that. All right, here we go. Boom, boom. All right, we got VA, negative VA. All right, low potential, high potential here. So let's write that equation down real quick. So we're going to do VA minus 20 volts divided by 10 ohms. All right, we're going to plus that. So we completed that wire. So that, oops. God damn it, I keep doing that, man. Man, where I can put this, where it'll be nice and neat. Yep. All right. So we've completed this wire. So this wire right here is completely complete. All right, now let's go to the next wire. Let's go to this wire. Let's label our points. We're gonna label our points. Obviously, this is the low potential. This is the high potential. Here we go. All right. So let's write the equation for that. We're gonna do the high potential of VA minus the low potential of ground, which is 0 volts, and we're gonna divide it by the 20 ohm resistor. All right. Divide that by 20 ohm resistor. I'm gonna add that. Right. Okay. Let's do this now. So where am I at right now? All right. So we're gonna go through this current source, right? We went from negative to positive, right? So if we went from negative to positive, that is going to be. Hold on, let me think about how I want to explain this real quick. I want to think how I want to explain this. Okay, so I think I understand now why this is this is all equal to zero. The reason why this is all equal to zero is because we're finding the opposite sign of all these currents, right? So theoretically, the universe already knows what these currents are, right? But we don't know what the currents are, right? So what we're gonna do is we're gonna find all of the opposite signs of these currents, which is why we're subtracting. Even though in theory, I mean in reality, right? VA is not the high potential, right? In reality, VA is not the high potential. It's because it's gonna go from low potential to high potential, right? Because VA is gonna be low, and in this instance, the 20 volts is gonna be high, right? So the electricity is gonna want to travel this way, right? Okay, so basically what we're doing, right? So let's say in theory, okay, let us say in well not in theory, well yeah, I guess in theory, let's say this is 5 amps, right? This is 5 amps. This is 2 amps. This is 3 amps, right? Okay. So basically, what we're doing is we're saying positive 2 amps plus negative 3 amps, right? Or hold on, let me write this a better way. Actually, no, we'll keep it like this. So we're saying positive 2 amps plus positive 3 amps plus negative 5 amps will give us zero, right? That's basically what this is trying to say, right? Or this equation is trying to say, which is why all of that is equal to zero, right? So what we're gonna do is when we're traveling from this negative terminal to the positive terminal, right, of this current source, what's gonna happen is hold on, let me think about how I want to explain this. So I explained how the equation works like correctly. Like that's exactly how the equation works, right? Or like the idea behind the equation. Now, um so the problem is though, as we go through this current source, right? As we go through that current source, right? You would think this was going to be like a current increase because we're going from negative to positive, so we're getting more current. But in reality, like no, we're actually getting a current decrease. When we go from negative to positive in a current source, that is a current decrease. So we're that's gonna give us that is going to give us -5 amps. Now I can't, and all of that is going to be equal to zero. All of this is going to be equal to zero. Now I don't know exactly why that is. Why when you go through a negative terminal of a current source, you're going to get five negative. I mean, you get a current loss. I can't explain why that is, but yeah. So we have that, right? So now let's just do our basic solving, right? So we're gonna have VA over 10 and VA over 20, right? So we're gonna do basic algebra, right? So hold on, let me write this down. So we're gonna do basic algebra, right? And just to also let you know, the reason why we didn't quote unquote complete that wire is because we already know the current on this wire, right? The current on this wire is given to us through the current source, which is 5 amps, right? So there's no reason to do all of this because we already know the current on this wire, which is 5 amps. But we don't know the current on this wire right here and this wire right here. So that's why we did that. All right. So let's see. So let's do basic algebra. So we're gonna do VA over 10 plus VA over 20. So we're gonna have 2 plus 1. So that's gonna give us VA 3 over 20. 3 is a prime numbers and it can't go into 20, so that is in simplest form. So VA 3 over 20. Right? And that's gonna be equal to 20 divided by 10, which is 2. So we're gonna have -2 plus 5 amps, right? -2 plus 5 amps, which is gonna give us -7. And we bring the -7 to the other side of the equation, so we're gonna have +7, right? And now we want to, of course, do basic algebra again. 20 times 7 is 140. 140 divided by 3. I don't even think that's possible. Is that possible? 140 divided by 3. 140 divided by 3. Nope, it's not. All right, so VA is going to be equal to 140. VA is equal to 140 over 3. Let me what's different? 0. 140 over 3. And here we go. All right, what is 140 over? Let me see where my recording is at. Okay, we're good. What is 1 over? So 46.6. That's what VA should equal according to our math. So let's see if that's right. All right. Yep, 46.6. Is that correct? Yep, that's the calculation. We got 46.6, and it says it right here too. So, yep, there's that.